Good evening, everyone. It's Advent of Code time. As you probably know, we're not exactly like caught up here on the latest days, which is why even though there's 30 minutes till the next puzzle comes out, we're about ready to get started. But of course, I'm not doing the next puzzle. I'm a couple days behind. Also just finished dinner, so I'll probably be clearing my throat a bit. Sorry. Also, Today I decided to try the ultra low latency streaming setting on YouTube, which, you know, what we're streaming is not very graphically demanding, so it seems like it probably ought to work without like too much of a hassle. I mean, apparently you can't stream in like 1440 or 4K, which is fine. I'm only uploading at 1080. That's the word I'm thinking of. So no big deal there. Day 15 should be exciting. Maybe we'll get to 16 today too, although I suspect they're both kind of longish, so probably not in one stream. Anyway, I guess I'm just gonna get started here. Day 15, chitin. Oh right, yes. So we looked at this a bit yesterday. You know, I could read the flavor text, but basically this is a grid of weights, costs for movement, right? You start in the top left, you want to get to the bottom right, you can only move the 4 compass directions, and every time you move onto a cell, it costs you that amount. So to go from, if you were here, going here costs you 3, going here costs you 6. If you want to go up, that costs you 3 as well. So I'm not sure exactly what they're going to do for part 2. Maybe they would allow you to travel diagonally? Probably not. What else could they do? Lowest total risk, any path from the top left to the bottom right. Huh, I don't know. I mean, I've been on the subreddit. I see people posting their like animations and stuff, which is fun to look at. I didn't see anything that was obviously like a part 2 thing, and I don't really go hunting for these spoilers. Sometimes I see them because I like checking out what people are up to. But I don't know what you would do for part 2 with this. You know, if they could say, oh, actually you have to start from the bottom right and go to the top left, but that wouldn't be hard. Like for any, I can't imagine someone writing a solution so bad that that's hard to do. So what else could they do for part 2? I mean, like diagonal movement is a thing, but I'm pretty sure that's not it. I don't know. They might just say like, oh, actually weights of 7 are not allowed. Maybe. Well, no point speculating about it. We should implement it. And I did talk last stream about my plan to solve this, which I don't know. I guess like a popular pathfinding algorithm is Dijkstra's algorithm, which sure, I think it's fine. And a lot of people in Advent of Code used it, and that's lovely. For whatever reason, I'm like in love with A star, and it's the one that I like. The first pathfinding algorithm that I learned well enough to internalize, and in principle, it can like, well, almost certainly, A star will get us to the goal after examining slightly fewer nodes than Dijkstra's algorithm would, because it will bias search in the direction we're trying to go. That said, I don't think it will actually be faster. It will examine fewer nodes, but it'll spend more time on each node, and the number of nodes fewer that it will examine is not very many. So, well, I mean, I don't know. We can do our best. But A star is what I'm gonna do. I haven't like gone and like studied A star recently. I'd like to make sure I can re-implement it just like without having to like Google it. But we'll see. I don't actually have my coding window set up right now, so I do have to take a moment to go find that before we can get started on it. Okay, is this me? You guys see that? Very good. Okay, so day 15? Is that today? I've forgotten already. Yeah, 15. Okay, and once again, turn off the breadcrumbs. One of these days I'll figure out how to do it, and like what I might like to do next year, I don't know if I'm going to do it this year, is like not have a stack project per day, but have like one shared project so I can build reusable libraries and figure out like how that stuff works in Haskell. Basically, I don't know how to build anything except small self-contained islands in Haskell, which is good for advent of code. There was a couple of problems in some years where I did define a couple of modules. In particular, one of the years when they did pathfinding, I did actually implement A star like generically and put it in its own module and call it from the main like problem thing. So I could just go like fish that out of GitHub and I would have a finished A star implementation. But I don't think that's that interesting. You know, if you have to implement A star once every 2 years, like that's probably a good frequency with which to implement A star, I think. So let's get my input. There you go. It's a bit long. We can see that it's 100 by 100. Okay, very good. Oops. There you go. So the good news is the parser is pretty easy, I think. We've written a parser for grids before. I suppose we could go fish that out. Oh, actually, you know what I should do? Is I should make sure array is in my cabal file. When I was writing this like default cabal file, I did not realize that array is not like included by default. I'll be kind of impressed if import data array, if like, it doesn't know about this. I mean, GHCI does. Or I have like 3 different Haskell runtimes going now, right? There's the interactive Haskell in Emacs, there's the GHCI in the shell, and there's whatever HLS is doing. And HLS seems to be the one who's a bit clueless and doesn't know about this. Like what is this parse error even? Like what buffer is that? This is J15. LSP log, maybe? No. LSP Haskell. No. Standard error? No. So I don't know. I don't know. Like it's kind of annoying. I don't know where. Oh, maybe it should be in a FlyMake log, right? Yeah. Maybe. Error. Init function failed. Well, I don't know what that means. I don't know what I'm supposed to do about that. I don't know how to use I don't know how to use FlyMake really. We're just getting like and so instantly LSP is actually not doing anything for me. No, it's highlighting stuff. Like how is it doing that if FlyMake doesn't know what's happening? Or why does FlyMake not know what's happening if LSP is working? I guess. It seems to know that data array exists, right? If I said data array, it's like, no, that's not real, right? So data array is real, but whatever is driving the highlighting in Emacs doesn't understand it. So I think we want like an array. We want a few things. Let's see. I think last time I implemented search, I probably did it in the state monad. It seems like I might as well just do it in ST. It's just like state, but a little bit faster, basically. And less lazy, maybe. I'm not sure though. It might be just as lazy. So I'll probably want import control monad st at some point. I know there was also a year when I did a star without any monadic stuff, and it like is not that much fun, but it's not impossible. What other type definitions do I need? Well, we're gonna need like a type describing the fact that we're searching for something, but let's first start with new type cost is a cost of int. Actually, they call it risk, don't they? Sure. Cost would be a little whatever. Would be more normal, but they're calling it risk. It would be more generic. They're calling it risk for this problem. So this needs eq or I think we might as well give it num. And I guess, oh, actually, will you, if I load this, num is not a stock derivable class, but I thought you would offer to add deriving, no, whatever, apparently you won't. Language, generalized, new type deriving, thank you. So now risk 4 is a risk. I typed that wrong. There you go. So we didn't derive show, so it couldn't print the value, but now it can. Risk 4. There you go. And we need map. And I think we can use a strict one today. Let's call this one as a, just, well, I don't know. I don't think it imports anything weird. I don't think it uses any names that clash with the prelude, really, so this should be okay. And at some point, we're going to want to... What's interesting, I think, or what requires a little bit of thought, is what exactly is going to be the types in our map. We want... Oh my gosh, I'm in the wrong window. Okay. We want, like, type... Type... what is the key of our map? I think that's kind of the most interesting, most, like, fundamental choice. We'll call it a key, even, for now. We can rename it later. So a key is... Why do I want a type alias? Why should I make it tuples? I don't think that's a good idea. Data key is a key containing several things. Lowest total risk is what they want. So it would be nice if we could find the actual path that we took. So that's going to have to be in here somewhere. Let's make it a record, actually. Actually, is... Can I... Well, I can derive ord for this, right? Yeah. Okay. Data coord is a coord of x and y, both int. Okay, so a key contains several things. First, it probably needs a coord in here somewhere. We're going to have to reorder these so that the deriving ord derives things in the right order, but let's just write down what needs to be in a key. So when we're exploring a state, we need to know, or exploring a node, we need to know where on the map that node is. Yep, that seems fair. We're also going to want a list of coord, which is how we got here. Path, right? And it can be in reverse order because it's more convenient to put something at the front of a list than the end, and I think that's fine. I don't really care about the order that much. And if I do, I can always reverse it at the end. Alternatively, if we really cared about performance and about keeping the list stored left to right, we could use a difference list here instead of an ordinary list as efficient addition on the right instead of the left, but we don't need that. And we need a an estimated cost and a real cost, I think. Do we need both of those? Like, because we're going to put these into keys in a map, which is going to sort them, and we need like to sort by estimated cost so that we explore things in the right order. Am I like doing something wrong here? I'm still not like 100% in my brain, but let's just talk for a minute about A star. So how does A star work? We talked about this at the end of the last episode. But basically, you maintain a frontier of nodes that you are planning to visit soon. They're adjacent to nodes you have visited so far, but you haven't yet visited them. You maintain a set of nodes you've already visited, which you will never go back to, because you make sure you always visit nodes in the most efficient order. And on the frontier, you have to keep the frontier sorted by, I guess, you would sort it by the cost that you estimate it'll take you to get to the exit from there, plus the total you've already spent to get there, right? So you do need both of those separately. But the problem is you need an estimated like total cost, which is the cost you already spent. Right, that's got to be the map key, is estimated total cost and not estimated remainder cost. So in some sense, we have to store so far, oops, I don't need two underscores, so far and estimated total, both of type cost, right? And really, these have to go first, so that the default ORD instance will sort by them. And these should be in the other order also. I said estimated today. All right, whatever. We'll do that in a minute. This should be underscored. There you go. Not that it super matters, but if I don't underscore stuff, I end up I don't like to use accessor functions very much. And so not having the underscore on just means that I end up accidentally shadowing them with locals a lot. And it also, putting the underscore on means that if I start using lens, it'll just be easier. Okay, so is this is what we need for a key, I think. I'm like, I wonder if it might just be better for me to get some practice with the Dijkstra's algorithm. I know I sort of promised an A-star implementation, but this is just like not a good problem for A-star, and it would be good to broaden my horizons a little bit. Let's go look that up. Dijkstra algorithm. Here we go. So blah blah blah. So you exist shortest path between two given nodes. Shortest path, okay. Presenting shortest path 3. The original found, okay, but which is all we want really. Finds every shortest path. So basically, I suppose you basically just. Okay, could you like tell me how it works? Starting at the initial node, the distance of y, the distance from the initial node to y. Start with infinite distances and try to improve them step by step. Okay. Find every node a tentative distance value. The shortest path discovered so far. Why, I wonder, do they make you create a set of unvisited nodes? I guess, like, so one nice thing about A-star is that it doesn't have to visit all the nodes at all, right? Dijkstra's algorithm visits them all. I think, right? They're gonna, by the time when they get here, are they gonna stop or keep going all the way to the end to finish up their? We'll just watch this for a minute. Okay, so it does keep going. Oh no, it stopped. Okay. For the current node, consider its unvisited neighbors and calculate their tentative distances through the current node. Easy, yes. Assign the smaller one. When we're done visiting all the unvisited neighbors of the current node, consider its unvisited neighbors. Calculate their tentative distances through the current node. Yes, that's easy enough because we know the cost to the current node, right? Or the tentative distance to the current node. Select the unvisited node. Okay, so we mark nodes with tentative distances, but don't visit them. Okay. Now, how does this actually keep track of the actual path you took? I see that this computes the weight. Which is fine for our part 1. We only need to know how expensive it is to get there. We don't need to know how we got there. I mean, I guess you could annotate each node with, like, not just its tentative weight, but also the node that you came from to give it that tentative weight. And then at the end, you can recover the path by looking at the destination and saying, how did I get here? How did I get here? How did I get here? And kind of doing that in reverse, right? Because I'm looking at this, and the algorithm, and I don't see how it could actually give you a path. It just tells you the weight. But as I say, it's not that expensive to I lost track of my sentence. Description, you look the shortest path. Starting point, okay. Okay, so here's where they actually do it, but where do they describe prev? Next hop on the path from the vertex to the source, yeah. So, indeed, as I predicted, this is kind of how you recover the path when you're done. But I'm just surprised they didn't describe that above. Yeah, and like we can use a priority queue. I think we're just gonna use a map, like keyed by where the first key is like the cost. Faster computing times than using a basic queue. Oh, because they iterating through the whole path in their algorithm? Vertex in queue with minimum remove. Yeah, okay, whatever. Yeah, so this is how I would normally do it. But sure, I mean, we can add them all, I guess, since we know what they all are. What are they talking about? Decrease key? Why do you need decrease priority or decrease key? I don't understand what that means. Yeah, so okay, so this doesn't instead of keeping an open set, we keep like a visited set basically. Or no? It's the opposite, right? Usually you keep visited, this keeps unvisited. Okay. Well, let's just do it that way. It's obviously not super different from ASAR, except you don't get the heuristic. So our key is going to be simpler here. I mean, do we even need a key? What is it we really have to be able to do? Yeah. We have to get out the vertex with the minimum distance. So data key is a key of dist risk, which is a risk. And then I think the only thing we need, well, if we'd like the path, it would be kind of nice to say previous is a coord and coord is also a coordinate. So if we put these as keys in a map, they'll be sorted by risk. So we can basically just use a map as a priority queue, which is nice. So the description here uses distance, previous, and queue as kind of 3 separate data structures because it's a very impoverished language that they're working with. I guess it's a... We kind of like should be working in terms of structs, right? We should, but the problem is we still need to keep data about things that are not in our queue, right? Which is why in such a data structure, okay, right. Instead of filling the queue with all nodes in the initialization phase, it's also possible to initialize contain only source. Then decrease priority, okay. I hate that they have these side data structures. They're just working in languages where like they're like, oh, you can't ever allocate an object. It's too expensive. Like, are you kidding me? But okay, whatever. So yeah, I mean, it is kind of... I mean, if we don't actually need the path, and I suspect that we don't, we like don't need an extra data structure to store it. We can just look at the total cost when we get to the thing. So let's just try that. Let's not bother storing a coordinate at all. And then if we have to go back and edit our algorithm to recover the path and do something with it, then I guess we can do that. So what actually is going to be in our, like, the value of our map? Nothing, right? So we're just going to use a set, actually. We have a set of currently of nodes to explore. And we'll just keep going until the node that we choose to explore is the exit. Okay, so actually we don't want this. Data set as S then. I guess we could say, I don't know. Just a set of key is a pretty simple type. We don't need to give it an alias. So let's just write lowest risk is a function from array of coord risk. I don't need parents there. To risk, right? No. We need to also tell it, I mean, okay, I guess we can just say we're going from the start to the end. The top left of the array to the bottom left of the array, that can be implicit. You know, we could be more generic and say, you know, we could write a much more generic search function, but I'm like, I don't really feel like doing that today. So lowest risk of A is something. I thought, like, do I really need ST? It doesn't seem that complicated. To just do it recursively. I mean, it certainly actually would make it easier to recover the path, wouldn't it? If I just had a couple of, like, if I just had a distance and a previous, I could, like, just transcribe the algorithm from Wikipedia, basically, right? Let's try that. It's always kind of a fun exercise, I think, to just, like, take some kind of unenlightened hoi polloi imperative algorithm and say, you know, okay, we could translate this to Haskell using, like, functional concepts, and I think that's often a good thing to do. But Haskell also gives you the tools to write in kind of a different style, in an imperative style, when you want to. So let's do that. Actually, is a function of graph to source. All right. So let's just say it's run st of do. So it says we should create a vertex set q. So let's just do that. Q is new st ref of s empty, right? We'll figure out what to do with q later. Next, what do we do? For each, for the graph, which is in the indexes of the array. How do you spell that question? Data.array. I mean, I guess you get its bounds and then you ask for the range, basically. I'm in the wrong module data.array. Here we are. List array bounds indices. The list of indices of an array in ascending order. So for indices A, do. No, hang on. For indices in A, lambda I do. There you go. Now back to the algorithm. Okay, we need distances and okay. Well, I really need the distance thing. I'm like, I hate reading code. It is the worst. I don't think we actually need the distance thing, but let's we don't need previous either. So let's modify stref. How do you even do that? I don't use st like ever. Modify stref. you modify it and you pass the ref and then the function. That's not a surprise, but I thought I would check. Modify stref of q s dot insert I. Is that all? It does say to make the distance for this be infinity. Is that necessary? Oh, also, right, we can't just insert I because I is an index and we need to insert a key. So let's insert key max bound no, I don't need it there. I need it here. Key max bound and I. Right? And I mean, really, we don't need this do anymore. We just do that. The funny thing is, we also don't need. Oh, hang on. The dollar signs are going to make things a little bit funny. Let's just leave it in here so that it looks like the Wikipedia pseudocode algorithm. Fine. We've now made our queue that we're trying to explore. And then we want to adjust, modify, it kind of, all right, why am I trying to be smart? Why don't I just do it like, I guess it was because I wanted to make it easier to find the lowest cost thing, right? There you go. Tail of indices. Genius. So now we haven't inserted the top left coordinate. And we can modify stref of q with s.insert of I guess we're going to look at the first of the range of A. A key of 0 and first of data.array. How do I actually get its range? Bounds. First of bounds of A, which should be a coordinate, right? All right. Does this like compile at all? Line 62 parse error? Excuse me? No. Line 11, column 62. Modify S. What? Where is ST ref? Oh, it's in ST ref. It's not in the same. It's not in the ST package. Okay. Couldn't find control monad ST ref. Where? Oh, it's in data ST ref. Things get weirder and weirder. Why is it organized like this? And 4 is in data foldable or maybe data traversable. I don't know. Data fold. I'm sure we'll need more stuff from foldable eventually. Couldn't match type unit with risk. Well, fine. Let's just return undefined. I just want to see if it like works so far. What? Could match type STS B0. Oh, I have lambda I twice. No instance for indexable chord. Okay, you got me there. Ah, this won't be, it won't be able to drive this, will it? Oh, it will. That's a surprise. I thought you could only derive indexable for like enums. Okay, I guess for products of indexable things you can. That makes sense. I just didn't remember the docs very clearly. Okay, so this compiles so far. Very good. Let us continue transcribing an algorithm from Wikipedia. While is a little interesting. I guess that must be in control monad somewhere, right? Let's just look at what's in control monad, shall we? Oh my god, I have to read through all this shit? I already know like what a monad is. Okay, so I want to know what cool functions are in here. Like, do we have while? We have forever, which I don't really need. There's fold m and stuff. That's cool. Guard when unless. I know we can do the recursion by hand. Okay, I guess that's what we're doing. Let's just say search. Search. Let search equal. Yes, it should be internal to. It needs to close over the queue if nothing else, right? So I mean, I could call search of queue, but that seems a little weird. So let search of. Do I need any conditions here? We're gonna stop as soon as we find the. So I think we can just say search equal. Two. We'll define a variable named u, just like in Wikipedia. Let u be let's look at data map. Because there's some kind of like find and remove minimum function, which is exactly what I want here. Data map strict, please. Query min max. Lookup min, yes, okay. Oh, but I have a set. I don't have a map. Okay, so I have a data set. Min max, lookup min. Okay, I'm looking for delete find min. S. Well, if it's empty, we're in big trouble. So let's just delete min of read s. No. I don't have a set. I have an stref of a set. Okay. So I guess I do need delete find max, or delete find min. Read stref of q. Write stref q prime. Q with q prime, basically. So we're saying find the smallest element in the set and delete it. And then write out the new, now smaller set back into the queue. Got it. You know, Wikipedia makes a good point. If you're going to do things this way, you might as well just, like, call s dot q prime, no, u find min of read strfq, and then we'll just write strfq of s dot delete u q. Okay, fine. Oh no, I can modify stref now, q of s dot delete u. Okay. And then we can say for the name. Hang on. I should destructure u, right? U key. Well, no, probably not, right? For neighbors of the coord of u, lambda v do something. Now they've written, I hate that this is like just so bad, right? They're saying like find the minimum. This is like a weird way of finding the minimum, isn't it? I don't know. So what is this algorithm saying? Consider each neighbor v. Okay, so the problem is we actually do need access to v, like to distances of a node, without having the node from the queue itself. Okay, right. So this is why I should have used a map to begin with. Import data map as m. And now I don't need this whole key thing because we're just not going to store that. And we're going to say dist is here also a new stref of m empty as well. For tail indices n, do they're calling these v, which I think is a good find now that we're not actually insert v. God, this is so bad. I can at least do better than this now that I'm not doing anything here. I can just compute the starting value by hand, right? New stref of s from list indices a. And then I don't actually need to write infinity. I can just handle if the thing isn't there. We don't need this at all. q insert, and now I don't need this either. Okay. So we removed you, and now for each neighbor, which of course we'll have to write, obvious tref of q for each neighbor lambda v do so v already has a tentative distance, or may have a tentative distance assigned to it from some other approach, right? So if we're not actually tracking the previous, distance of view. Oh, there's not a loop here. There's just like two things. I mean, we're in a loop, but yeah, okay. Let's just let. Okay. Alt will be s dot, no, we have a map, m dot find, oh no, okay, what's in data map? How do I get something and like find a default or something? Query, lookup, maybe, find with default. I think, I mean, lookup with maybe is pretty good. That's better than some weird infinity hack. So m.lookup takes the key, and we're looking in the distance map for u. Read stref of dist, right? I guess I don't need these parents. Plus 1 basically, because we know the distance from u to v is 1 in our weight. No, we don't. That's crazy. We need to look in the array for u. So a u. So we're looking up in the distance map u, and then we're adding the distance from u to v. And then I guess we can just say when alt less. I have to read distance of v first, right? I think I could just say update v with something. But no, because I have to also do something with. I have to. Well, no, yeah, that's fine. We're ignoring. Sorry. Oh, you guys can't even see this. I forgot to switch back. Okay. I don't know. I think you weren't there for too long. I just wrote this. What we need chat for, but nobody's here tonight. So what I was looking at is this, right? This is what we're about to implement. If alt is less than dist, then like do something. But as long as we're not actually saving previous, we can just like say update the entry in v of dist, or update the entry in dist for v with, and then we'll like look at alt and the current distance and decide what to do as a result of that, right? So modify stref of dist with m dot insert with min. Alt B. Just guess. It should be fine. I think that's actually right though. So if we look at insert with, it takes a key or a key combining function, a key and a value, and then a map, and that's what we have here. We have a key combining function, a key, a value, and then the map kind of implicitly being passed in via modify stref. Then what? What do we do next, though, oracular Wikipedia? It's returning. Okay, so what we need now is to say if you, hang on. When are we done? Yeah, we can stop as soon as we get you out here. Actually, but okay, we can also explore from. We'll just put it here because it's an easier place to return. If u equals. How do you get the like the limits of a? Well, I guess it's sund of bounds of A, basically. Then I just need to look up the distance of u, right? Read stref. Does stref have like? Does read? Okay, it doesn't have any. Everything cute you might want to do is you do with fmap or something. I guess I should use modify strict. Whatever. Read. So we have. U is our coordinates. That's the exit, and we look in dist. So m dot get of u. Read stref of dist. I think we're just going to return that. Look up the cost. Else. Search. All right. How many type errors are there? Ambiguous occurrence. Oh, yes, that's correct. This should be a dot. Oh, I haven't. All of these should have been qualified. I forgot that if you do as, it like does some wacky thing where it imports them all and also gives you the qualified name. Actually, maybe that's not insane. Is that what I want? All right, what data array? Oh, I didn't qualify it here. The last thing we can do must be an expression. Oh. Search. So we defined what it means to start searching, and we gave it a name because it needs to be recursive, and then we have to actually start searching. Disk? Well, that should probably be risk, huh? Oh, no, we called it dist. That's why I was confused. Found hole underscore coord? It's just neighbors of u now. We got rid of the chord function. Variable non-scope neighbors. So indeed, we haven't done that yet. So neighbors takes a chord and returns a list of chord. And neighbors definition is, it doesn't have one yet, but shouldn't be hard. The mesh type may be risk with risk. m.lookup_u in distance. Okay, what exactly was going on at that point? Distance of u. Well, okay, we know that u definitely has a distance in it, right? Because we got to it via v, and v assigned a tentative distance to it. So we can ignore the maybe possibility. Okay, it says it compiles. So I think it's actually kind of, you know, I'm not well set up right now to give you guys a side-by-side, but like, this is a very, very imperative-looking function, right? We define a bunch of refs, and we make all these side effectful things where we modify the values in those refs, and we say, oh, just iterate over this and do something for each element, right? Rather than like say, oh, we're going to fold, or we're going to map, or we're going to filter. And okay, so I don't have proof yet that this is correct. So I don't want to like brag about it or anything, and also I don't like it because I kind of hate doing this imperative style thing. But I thought it would be an interesting demonstration to be like, look, you know, Haskell is this functional language by default, right? It doesn't, you don't have to write everything in this style where you turn everything into folds and stuff. If there's an already written imperative algorithm, you can like just use it because Haskell gives you the tools to, you might say, opt into additional language features by what monads you use in your, you know, you get kind of like non-determinism if you use the list monad. You get kind of, I mean, it's not really non-determinism, but it's one way to model non-determinism. You get something that's kind of like null, you know, automatic short-circuiting on null if you use the maybe monad. You can have mutation if you opt into ST, and there's all this, you know. So when it's suitable, just use it. There's no shame in using ST, and it's not inefficient either. ST is, it actually does compile down to like when it can, it modifies stuff in place, which is kind of cool. So I don't know, is this correct? It's hard to say. So neighbors, but okay. It's been a while since we wrote a compass or a cardinal direction neighbors function, huh? Neighbors of, what is my coordinate type? Chord of x, y is, I mean, we can just write it by hand, basically. Chord of x plus 1, y, chord of x minus 1, y, chord of x, y plus 1, chord of x, y minus 1, right? So it would be kind of interesting and very useful, I think, to test this somehow. But I think that even the example array that they give us here is too complicated. If it goes wrong, how will we know what to do? So I think that what I will do is test it on a very, very simple array. So let's try, what did I even call my function? I forgot already. Lowest risk of array from 0, 0, let's call it list array even. List array from 0, 0 to 1, 1, 1. It'll be a 2 by 2 map. And we just want to know, is it faster to go east than south or south than east? So we'll say it costs 1 to be where you started, which whatever. And then 2 to go east, 5 to go south, and 3 to arrive at the destination. Oh, these are supposed to be coords? Okay. I forgot, yes. Error. Great. Yep, told you it wasn't right. Given key is not an element in the map. What map exactly? Well, we only have one map. And the only place that we... Is V what I was supposed to write to? Oh, I forgot an important step in the algorithm. I should have just copied Wikipedia. I forgot this step here. You have to initialize the source of the distance of the source to 0. Great. So that's an easy fix. Who knows if it'll fix everything, but we'll say it's a new stref of m.fromList of well, okay. Let start equal, you know what? Start end equal bounds A. And now, when I have this first and second garbage, I said starred. Did I miss something here? Okay, anyway. M probably has a singleton method, right? It does, okay. M.singleton of start 0. Don't I have like a first or a second in here somewhere? No, I don't. Okay. Still compiles? Good. Wait, I'm in... Oh, right. This is... Okay. All right. Well, I'm using Emacs as GHCI for some reason today. I don't need to do that because it... I already did it by... Okay, whatever. Hey, risk 3. Is that right? It went east, and then it went south, and it got the wrong answer. Fantastic. It was supposed to be 5. It was supposed to go east and then south. Okay. Well, here's a question. What cost do we get when I just say you're already at the start? 0. Okay, great. That's good news. And if I say there's only one other way to go and it costs 4 to get there, it says 1. So that's not right. What did I do wrong here? So for each... All right, so what is U? U here is the... Wait. Oh. I didn't adjust for the fact that my set is no longer in sorted order. I had assumed at some point I was going to find the smallest item in the set, which was going to be ordered by cost, but now it's just in an arbitrary order, and I have to actually pick the smallest. So what I'm actually supposed to do is find the element with the smallest entry in the distance array, which I kind of hate. Open will be this. And then I kind of want minimum and map m to map m over. Okay, so u is minimum of map m, which really is just traverse. You know what? Let get dist of n equal. Are these all going to have? Oh, the problem is I haven't actually initialized my array with my distance map. I said I don't need to put in the infinities. Yeah. So it's not so easy to get out the node with the smallest distance. If they all have length infinity, that would be kind of a surprise. And I can't even, like, if I can map reading. All right. Oh, I can just use find with default max bound. That's why I put a bound on risk. M dot find with default of max bound n read stref dist, right? I can say get dist now. Of open. Let's call them opens. And here I'm using bang, but really m.bang u. I guess that makes sense. Sort of. But I think that this whole thing now is just get dist of u, right? Right? Yeah, so like that. Does this compile at all? Have I finished? Mesh type risk with coord. Oh, indeed. U is the... Right. U is the cost, not the node. This is miserable. Working in this imperative soup. So, like, I guess I can just fold map and implement minimum myself, basically. Well, I don't need to fold map because I can just traverse get dist out and yeah. Fold R. No, the problem is right. The problem is now I only have distances. I don't have nodes. There's probably some like map QML or something that I could use here. Probably. Or map. What is map QML? It's intraversable, which is promising. It applies a function to each element of a structure, passing an accumulating parameter from left to right, and returning a final value of this accumulator together with the new structure. Okay, that's not what I want. All right. I think I'll just use fold map and I'll do it myself. Cheapest. What is the type of fold map? Oh. Right. I don't really have a... Right, map M is what I want. Map M, thank you, which is traverse. And I know what the type of traverse is because it's just map M, so why am I even looking? Okay, so traverse... No, wait, but this is still not right. Oh, I looked at map M, I meant fold M. It's not fold map, it's not map M, it's fold M. Here we go. So it's like a fold L, except that you do monadic actions when you're combining two items. Instead of BA to B, you get BA to MB. And T is the list of items you're folding over. Okay. Yes, that's what I want. Fold, ugh. Traverse fold, ugh. Yeah, that's about where I am right now. Fold M, cheapest of opens and... Is there like a fold M1 or something? Where I can say, I promise that there will be at least one item? That would be in like foldable 1, which doesn't in base these days yet. Maybe ever? All right. I guess we'll fold over maybes or something. I hate it. I don't like that at all. Also, I need to put that argument here, of course, not there. So what is my base case? Like it's... Like how do you So what we should do is annotate the nodes with their cost. Weighted traverse lambda v to v get dist v there of opens. So now I don't have to work in any dang monads, and I can just use like minimum and cheat, right? So let's have let u equal minimum by. How does minimum by work? They want me to pass comparing, or yeah, it does. Comparing second weighted. I'm sure I have to import those now. Import data list minimum by, and comparing might be in Prelude now. I'm not sure. Couldn't match coord with STS risk. Well, that's a surprise. Line 32. Oh, well, this, by the way, could just be get dist of u. Yeah, I mean, it's not a huge surprise that it's wrong. All right, let's see if GHCI can tell me a little bit more. Oh, I have GHCI open in Emacs already. So I think there's like a lot of things wrong, and it like doesn't know which one of them. It's inferred a lot of types, and like it found something was wrong, and it's not sure where to point out the error. Okay, so one problem is that our queue is not a list, and who knows what traversing over it is going to do. So unsurprisingly, this is like still wrong. Get out of here. What are you? How did that text get there? Okay, so it needs comparing, that's fine. But what is this shit? Oh, of course. Traverse. I can't bury the effect here. I have to. Okay. Do the. I mean, there's fancier applicative ways to do this, but that should be better. It doesn't like that I don't have comparing, which, where is comparing? It must be in data ord, right? Okay. So somewhere it expected a set of coord, and I got a set of pairs of coord and risk. Yeah, that's true. I did make that mistake, didn't I? here, when I computed the weight, okay, let u weight u be this, basically. No, it's u and weight. And we don't care about the weight, so we'll just tell GHC that. Okay, so that was the main thing that was wrong, is I projected into a space where I have an extra, I have a tuple, and I forgot to, or, what's it, there's projection, what's the opposite of a projection? Embedding. So I think I always forget which is which. And projection is when you make the space smaller, right? So I embedded myself into a space where I have a tuple, and I forgot to project back down into the space where we only care about the nodes. And if I'd put type annotations on some stuff, GHC could have helped me more. All right. This function is no longer like an amazing thing to compare to the Wikipedia algorithm. It's kind of disgusting. Okay, but you can write imperatively. That's the takeaway here. So if I were to say, how do I? There we go. This is what I want to run again. Risk 1. Well, this is still wrong. And I assume this is still correct? Yes. So how have you concluded that you can just walk there in with a cost of 1? Like, that shouldn't even be... V. Right? Is that right? No. Oh, something is wrong here. What was there before? They were both U. One of these is supposed to be V. And it should be that one, right? U is where we're thinking of going. And V is where we already are. So we look up the cost of V, which we know exists. And then we add the cost of U. Still says 0. Oh, that's because that's the small one. That's not great. Why is it negative? Did I accidentally use min-bound somewhere? What? Oh, get dist of V must have returned a negative number. Oh, right. It is the opposite. V is where we're going. And therefore, like, we should look up its cost in the array. U is where we've been, and we should look up its cost, cumulative cost, in the map. There we go. Now it says risk 4. And if I say, like, I had a bigger one in mind, right? It says 5. That's good. It went east for 2 and then down for 3. And let's just give it one slightly bigger test. So from 0, 0 to 2, 1, there should be 6 things. 8, 2. So what does this mean? So I said there are 3 rows and 1 column. So you can get from 1, so that it goes 1, 5, 8 all on the left and 2, 3, 2 on the right. So it should definitely go 2, 3, 2. Total cost should be 7. Great. Okay. we finally did it. We implemented an algorithm. We're real computer scientists now. So basically now we just need a parser and a very trivial part one. Our input, of course, is not really a list of string. It's an array of coord to risk. And we need a better prepare function. So prepare input let L's equal lines input in, I guess we can just say a list array from chord 1 will be the top left, I think, to chord of length L's, length head L's. So yeah, that sounds right. And then we need to provide the elements. So we're basically just going to concat together map digit to int of concat L's. Import data char digit to int. Does that parse? Does it compile? Oh. Oh, these don't, that doesn't, we don't need actual. This closes that closes the tuple. A big occurrence map, prelude map. What other maniac imported map? Oh. All right, fine. Good match type int to risk. Okay, sure. This compile. Great. I think part 1 is just lowest risk. That's it. All right. I mean, we can try running it. I'm not optimistic. This is taking way too long. It shouldn't have taken anywhere near that length of time. It's only 100 by 100, and oh, I guess the problem is that we used a really bad data structure, right? We didn't end up using like a heap or even a map. We used a list and just got the minimum every time. So it had to do 10,000 comparisons 10,000 times. So okay, I guess that's a little. 447 though, is that plausible? Like, Let's just do a sanity check on that. It seems okay, right? Like, the best you could possibly get would be 200, right? 199, I guess. If there was some straight line path that was all ones. 447 means that you're getting an average cost length of like 2 and a bit, which seems pretty all right. That is the right answer. Okay, well, that's what I get for being pessimistic. Let's commit this monstrosity before we look at part 2. Day 15, part 1. The entire cave is actually 5 times larger in both dimensions than you thought. The area you originally scanned is just one tile in a 5 by 5 tile that forms the full map. It repeats to the right and downward. Ooh, okay. Well, alright, we might need to use a better structure. I mean, there's a little bit of work here in like building the kind of virtual array. We could just build the actual array. It's not expensive to make an array that's 5 times bigger, right? 500 by 500, basically. But it would cost like 100 times longer or something, right? Let's just real quick here, time stack run, and see just how bad it is. Because we're if we don't do anything, we're looking at making it I think more than 25 times worse. So it runs in 10 seconds. So if we made it like 25 times worse, that would be like 4 minutes, which is like bearable. But I think we're actually going to make it like 25 squared times worse because we have such a bad like algorithm for finding the next node to explore. Yeah, so that's not great. All right, that's fine. So let's look up actually, I guess, heap. So is there a good heap? Priority queues extended with support for okay. This looks pretty good, and it's by Edward Kmet. Like it's got to be good, although I bet the types will be confusing. Maybe. So it's a priority queue, a min heap of values of type A. So an entry is a priority and a payload. Okay. So what exactly can you do with a heap? Right, like, because heaps are one of those data structures I never quite got. So maybe this is an opportunity to learn it. Okay. There's a priority payload tuple. And a heap is a min heap. And when you insert a payload and a priority, if I have a heap of A entry, empty, yeah, okay, size, singleton. Oh, I see. You can build a heap out of any type you want. I'm a little surprised nothing needs ordering or anything. Oh, no, it does. Or day. There you go. Insert needs or day. I'm a little surprised singleton needs it, but okay. But the important thing, I think, is that you can, if you want, build a heap of entries. And if you do, what you get back is like a priority queue. Because an entry ignores the payload, which is the second field. Okay. But my I guess like the problem is that the Wikipedia algorithm we implemented is the one that's not designed for a priority. I didn't want to look up how that works. If we had done this, you create a queue. You add everything. I kind of hate that part. Initialize it contain only source, and then. But why is it decrease priority? That's so. I guess the point is you're saying, okay, I have a payload that like I already knew about, which is the node I want to get to, and you're saying update the priority of that thing to be smaller. Is that something we can do with this heap type? I don't think so. Insert, delete. It's not like. You can't really get like you can't adjust the value for an arbitrary entity because a priority queue isn't just a map that also you can get the minimum of cheaply. That would just be a map. So what they're asking us to do in this algorithm is not something we can easily do, I think. Right, this like decrease priority is like not a thing we know how to do. I guess this alternative is the thing you could do with just a priority queue, where you don't have to modify anything. You just like say, okay, I found a way to this node and it takes like 100 risk, and you put it on the queue. And then when you get it out of the queue, you say, oh, I can get here with 100 risk? Like, I've already been here, and it only took 80 risk. Throw this garbage away. Right? You end up with a larger kind of internal what am I I saying? You end up with more kind of temporary garbage, but it's like kind of fine. I think this should be fine. So let's use. I think rather that'll work, right? So let's use heaps and say, hello, I need heaps, please. Yes, restart GHCI form. Yes. Show me the log. What's wrong? What do you mean the process has died? I mean, I guess I don't care. Oh, I killed GHCI here for something. So it's building heaps, which is fine. And it looks like we already have all of heaps dependencies, so it won't have to do a bunch more stuff. Cool. All right, let's just close Emacs and start over. Oh, you guys can't even see this. Sorry. Okay, so can I compile this? Your wish is my IO unit. I love these little quips. Like that one. An Emacs tradition. Most languages that have an Emacs interpreter often come with stuff like this. I first learned the ones for slime in spin closure, but I like this one. Okay, so we have a heap now. And we can say our distance will be a new stref of, well, let's import it the way Edward says we should. He says we should do this. You know, is there anything that I'm using? Like everything I'm using qualified, right? Let's just say qualified, and see if that like makes me stop compiling it. Array. Oh yes, of course. I need the type. Import data array. Oh, funny. I'm not using the types map or set. IX. Okay, I do need that from array as well. Okay, I actually am using quite a lot of things from array. List array. Oh, I guess that's fine. List array bounds. Just give me all of array, actually. That one's going to be my exception. Import everything. Okay. Cool. So that all works. Now, distances is going to be an stref of heap of I'm going to call it H. I don't know. Heap H. We'll call it H. An stref singleton of entry. The priority is first. 0 start. It's not M singleton, it's H singleton, right? That's a thing that exists? Yes. Okay, so now everywhere that I use dist is going to have to... Oh, no, I've changed the wrong thing. It's supposed to be Q that's the min heap, not dist. Right? Yeah. I guess so? So in that case, am I using the distance at all? These alternatives can use entirely array-based queues without decreased key functionality. What we're doing. Okay, so it says it wants, yeah. So it's basically saying, yeah, go ahead and like extract from the queue the priority queue, and then check against the distance array to see if you should actually do something. Okay, so give me import control monad guard as well. Not guard. When. H. Ugh. Okay. The problem now is that we're gonna have to like change our assumption, which is currently that the queue doesn't ever need to be added to. But I guess we can just add all the neighbors in our for each neighbor loop, basically. Okay. So it'll be h dot singleton of zero start. I already forget what order this thing takes stuff in. Not entry zero start, right? Entry PA priority first. Yes, okay. So the first thing we do is we have our distance still. That's great. So instead of all this nonsense about opens and weighted and so on, we're going to let minimum and delete min. What are the other functions? Is view min, I guess? Well, I guess we, okay. Entry, risk u from h minimum of read stref q h dot delete min q. Excuse me, had some sneezing to do there. We can throw away that. Oh yeah, can't just do this. This would be h delete min. And then we need to say when I guess what we need to do is look up the tentative distance for u, right? So tentative distance distinctly get dist of u, and then say only when risk is equal to tentative distance do. Ugh. I can't have to do this. It's so primitive. But so only when the entry that we're reading from the map, from the queue, is the fastest way we found to get there, do we do anything. If it's not, it means we put this on earlier as a speculative way to get here, but we already explored it because we found a faster way first. And so we just have to now modify stref we need to be a little bit careful because actually this part shouldn't be indented so much because we need to do this whether we process the rest of the node or not. We can't just say, okay, let's take this neighbor and add it to the queue, because this neighbor might be outside the end of the array, right? Do I have a bounds here somewhere? Yeah. So what we should say is when in range b. What order does in range take its argument? In module data.ix in range takes the bounds first. Okay, when in range bv, modify stref q with h insert. Is it called insert? Yes. H insert of entry alt, I guess. Oh no, the problem. Okay. Well, actually, I can just add it unconditionally here, can't I? Because if we end up finding a faster way to get to the node, we'll just throw this one away. Sure. I don't need to worry about that. So I think I can say entry alt v. Does this compile at all? Probably not. Entry, okay, h.entry. It does compile. Okay, so first thing, oops. Does it still work? if this is still taking a very long time. That's upsetting. It should have gone way faster, right? What took so long? I guess, okay. I see one. Okay, so just adding the thing back actually sucks. It means we spend a lot of time revisiting nodes that we've already been to. So I guess what we can do is say, we have a distance map. Okay, let's say old dist is get dist of v, I think. And it includes a max bound, so that's fine. We don't have to worry about maybes. When alt is less than old dist, do modify stref dist of m.insert v alt. I can ignore what was there now because I know what's here is better. And then I can actually shouldn't I put this when first on the outside? Like here? When in range of BV, do all this stuff. And then you can go ahead and, well, and then say when you found a faster way there, then go ahead and modify the distance map to reflect the faster way and also add that new way to the queue. Otherwise, we don't have to modify either. I'm really concerned about how slow this is running because I thought like we're suddenly using good data structures. Okay, that was the problem. Yeah, I was doing a bunch of work exploring exploring nodes over and over again and just counting on the fact that I was going to throw them away. But it meant that my queue was growing very large. Okay, so this is 0.7 seconds. And we're going to make it about 25 times slower. Not 25 squared anymore. Okay, so let's day 15 use a heap. Just been a shameful showing for me today, by the way. Okay, very, very, very slow. But now we have a lowest risk function that works on any array. And all we need is for part 2 to have a function from array to array, basically, that like builds a bigger array out of the smaller one. What does that look like? It's like not actually all that easy. I guess it's not that bad. We'll just map over the ASOKs of the old array. Flat map over them. And choose an X delta and a Y delta. I guess we're flat mapping over, yeah, the thing in the array and the X delta and the Y delta. Yeah, that shouldn't be too bad. All right, so let me make sure I understand how the array is built here. So it repeats 5 times to the right and 5 times down. And each time, the risk levels are 1 higher than the tile immediately up or left. Only when it repeats, right? Yeah, so these 1s each turned into 2s, the 6 turned into 7. Okay, that's what I thought. The way this is written made me wonder if it was like doing something else, but it's not. Okay, so that's not too bad. So part 2 produces a risk, and it's lowest risk dot expand, where expand of A is array of do? Probably. And we'll say coord of x, y, and r from ASOKs of A. Dx from 0 to 4. Dy also from 0 to 4. Pure of coord of x plus dx, y plus dy, and r plus, I need parens, r plus dx plus dy mod 10. Right? Couldn't match expected type int with actual type int. What? Why? So I'd say a dot ASOKs. Oh, I knew the right thing. Okay. Can I get a longer error message, please? Oh, I got my wish. Couldn't match expected type risk with int. That's fair. Oh yeah, you're right. I did try to add together an int and a risk, didn't I? That's a little. So I guess what we can do is just say risk r. We'll unwrap the new type here. I was trying to protect myself from like accidentally adding risks to ints, and here I want to do it on purpose. But you know, okay, it did protect me. If I had not wanted to do it, I would have welcomed that. Risk of this, please. Is that any better? I mean, maybe, but it's not all the way better. Huh? What did that first thing do? Oh, I forgot. Array, right, I have to tell it the new bounds. Okay. width, or it doesn't matter, I guess. H times 5 plus, or width times 5? No, this is not correct either. Okay, array from coord 1, 1 to coord of, we're doing these in, I don't think my x's and y's are right at all. It doesn't really matter. Coord of h times 5 width times 5. Where that doesn't look right. You should be over here. Oh, maybe not. Why does it want to put the where here? I would have thought it would go here. Where, coord 1, 1, coord HW equals bounds A. What are you still so mad about? What is the type of array? Am I crazy? It takes a pair of bounds, yes, and then a list of pairs of index and value. Okay, that's like what I have. Function? Did I forget to pass an int to pass a value somewhere? Cure of coord x plus dx, y plus dy, risk of yeah, I want it to be a pair of coord, a list of pair of coord and risk. It's apparently actually a list of functions, list of tuples of functions. Oh fuck. Okay, yes, you got me. All right. I put a comma in, so fucking sue me. All right. There you go. I made it look too much like a tuple. Okay. So can we just like run this? Would that be cool with you? Undefined array element. It's kind of sad. Did I forget to fill something maybe? Oh, yeah, I totally did. 5 times dx, 5 times dy. There you go. Oh, here was me so excited that it hadn't crashed yet. This is going to yield y plus 5, y plus 10, etc. We're starting with 0. That seems right. So we take the original xy coordinate. and then we add this delta to them. So that seems okay. What happens if I just say, please print out the array? I bet the array that I built has a hole in it somewhere, right? And it'll fail to print. But I want to check that, because if it actually prints successfully, it would mean there's a bug in the pathfinding code. But it doesn't. So how did it fail here? What? Y equals 60? Oh yeah, that makes sense, because this, I was thinking it was only like a 5 by 5 array, but no, it's 100. Okay, so that seems okay. X is 1, Y is 60. Like, that should be totally legal, right? Oh no, I see. I keep doing the math wrong. I shouldn't be multiplying by 5. I should be multiplying by the width of the original array. Or the height, or whatever. So not 5, but... Okay, let's be careful here. Not that it matters, width and height are both the same, but like I should be clear that if I'm pretending the x-coordinate is the first one, then I should also pretend the width is the first. And okay, actually, probably this is being stored in the opposite order, where like actually the first index corresponds to like a row, but whatever, you know, it doesn't matter. So what we need to do is say 5 times width. Sorry, not 5 times width. Width times dx, width times dy. Right? Yeah, that makes more sense. Okay, so there were no holes in the array this time. And it looks plausible. Okay. So please, oops. There you go. Bring that back. That's pretty good. That looks about right. It's about 5 times as big as the old one, but not quite. I'll take it. Too low. Well, Oh, you know what? I bet I did the modular arithmetic wrong. I didn't read the instructions carefully enough. How does this wrapping actually work? Because my solution lets things be 0, which is not correct. Risk levels are 1 higher, but 10 goes back around to 1. It doesn't go back around to 0. That explains why we got a lower risk. We found some lower than 5 times as much. We found some zeros in there. So we just need this function. Risk composed with 9 wrap, I don't know, of this. And 9 wrap of 10 is 1, 9 wrap of n is n, right? That number is like twice as high as the last one. Are we for real on this? I knew it would be higher, but it should only be like 10% higher than what I calculated, right? Well, no, maybe not. This is... Is it plausible? How much longer should the path be, right? We're going 5 times as far to the east and 5 times as far south. You would expect it to be about 25 times higher. And we got only 10 times higher? That actually seems like laughably low, doesn't it? I'm not going to submit this yet. It might, I don't know. I mean, I guess it's fine. It's not that embarrassing to submit something and be wrong again. And then if it's wrong, we can think about it. It's too high. I said it was embarrassingly low. Too high. Well, okay, now we know it's between 2,000 something and 4,000 something. We'll just binary search it, haha. Too high. Okay, well, you know what we can do? We can debug whether our like multiplying the thing out is a problem or something else. Well, the problem is expand is not a top level function. All right, well, let's make it one, shall we? Oh yeah, now you want to indent to there. Okay, so expand takes an array of chord risk and returns a new array of chord risk. We could make it take like an integer as well, which is like how much to scale it by, and that could be kind of cute, but I don't think we particularly need that. So suppose we wanted to expand a list array of chord 1-1 to chord 2-2 of uh, 5, 6, 7, 8. Yeah, that should be fine, right? My God, it's enormous. Oh, I was like, what are these 10s doing here? Right, those are the bounds. It goes from 1 to 10. So that's the right size. And, oh. Yeah, of course it's too high. I just realized what's wrong with... I was assuming in 9-wrap that we would only because the puzzle is presented as like increasing by 1, I was thinking, okay, if we have a 9, we've added 1 to it, and we get 10, we'll wrap it down to 1. But no, we're adding dx plus dy to it, which, you know, could be arbitrarily large. I'm actually surprised we were only like 10 times as large as the original, because it should have been... Something seems wrong. Okay, anyway, this is fine. We just need to actually do modular arithmetic here. So we need to do something mod 9, right? N minus 1 mod 9 plus 1. Is that right? That way 10 maps to 9, which maps to 0. And then is increased to 1. Yeah, that seems okay. N minus 1 mod 9 plus 1. I have no idea how this is parenthesizes, so we'll just go nuts with it. Okay. Let's try this again. Oh, what am I doing? Here we go. The Emacs thing. Here we go. So expand this again for me. And where should we first be? Like, what should be in the bottom right? That's a good question to ask, right? We had an 8 there. And it should have been increased by like 10, right? Because it's been scrolled off to the right 5 times and down 5 times. So it should be 18, which should be 1, right? Because when it turned into... You basically subtract... Yeah, the value should be 18. Oh, it should be 9, right? Because it should be 18, but that's too large, so we subtract 9, right? So if you had a 10, you would subtract 9 to get 1. 18, you subtract 9, and you get 9, and that's correct. So if we look in the bottom right at coord of 10, 10, we should get a 9. I see a 7, though. I hate that. Ah, no. That's not necessarily wrong. Because, I think it's right, in fact. Because it hasn't been increased 10 times. It's been increased only 8 times. Because the first time, it stays the same. Then it goes right 4 times and down 4 times. That's 8. And 8 is 16. We subtract 9, we get 7. That sounds about right. So let's run this. I'm really surprised still that this is only like about 5 times as expensive. Because aren't we traveling like 10 times as far? I said earlier 25 times as far, but that's not true. The x dimension has been increased by 5, a factor of 5. And that's been added to the y dimension, which is also increased by a factor of 5. Oh. So it's only 5 times as far. We have 5 times x plus y. Okay. Actually, this sounds totally plausible then. That's the right answer. All right, not a great performance from me today. But I played with some libraries I wasn't previously familiar with, and that's interesting. Now the question is, when are we going to do part 16? Day 16. I don't think right now. I could use a break. I don't actually have work tomorrow, so I'll probably just like tomorrow afternoon or early evening, maybe. I am looking forward to day 16. Seems like a somewhat interesting parser problem that, you know, you could probably just apply parsec to. There's a couple things that are going to be a little bit awkward to do with parsec, but it should still be better than starting from nothing. Anyway, let's get this committed. Day 15, part 2. Part at? Oh no. There you go. Okay. Cool. Well, nobody showed up in chat today. It makes me a little nervous that like I didn't properly go live at all, but I'm pretty sure I did. I see that people have watched. There have been some. YouTube tells me some people have looked at the stream. And someone even liked it, but nobody in chat today. None of the regulars. All right, so I guess there's no sense hanging around then. Thanks for watching, and I'll see you next